All right, so are you ready to dive deep? Because today we're looking at some notes,
Okay.
and they propose some pretty out there ideas about physics and reality.
Yeah.
Specifically, the idea that our current physics might be missing like a fundamental understanding of how reality actually works,
Okay. Yeah.
like the underlying machinery.
Interesting.
What do you think?
Well, it's a bold claim.
Yeah.
Right? It's like saying we've been so focused on describing what we see, the behaviors, the probabilities,
Right.
but we haven't really grappled with the underlying structure that makes all of that possible.
I see what you mean.
It's like we have the instruction manual for our smartphones.
Right.
But we have absolutely no clue about the circuits and processors inside.
We can use it.
Right? We can use it.
But do we really get it?
That's a good point. And to illustrate this,
Yeah.
the author makes this interesting comparison with machines that humans design.
Okay.
Okay, so think about a car, for example. It works based on its structure and its composition. Right.
Right.
Not by somehow like reading and following the laws of physics.
So what are they saying? Are they saying that the universe itself is more like a complex machine than...
Well, that's one way to look at it.
No.
The author seems to be suggesting
Yeah.
that maybe instead of focusing so much on like laws and symmetries,
Yeah.
we should be looking for, the fundamental parts and the interactions that truly make up reality.
Okay, so when they talk about the machinery of reality, what exactly do they?
That's where it gets really interesting.
Yeah.
I mean, they don't define it precisely, which kind of adds to the intrigue.
Okay.
But they do contrast it with our current physics concepts. Like, for example, they argue there are no actual parts in reality.
No parts.
Like the particles we talk about in quantum mechanics.
Oh, no, wait. No parts? What do you mean?
Yeah.
How can there be no particles?
That's a pretty radical statement, right?
Yeah, isn't everything made of something?
Well, that's the assumption the author is challenging.
Okay.
You see, that they suggest that our very perception of these separate particles might just be a product of our limited human perspective.
Okay.
And the way we use mathematics to model the universe.
So instead of thinking about these distinct particles interacting through forces, are they suggesting like a continuous kind of interconnected reality?
A seamless tapestry.
Okay.
Not just a collection of separate threads.
All right, so that leads to another kind of bold question.
Yeah.
They say reality does not read laws.
Right.
And that's a head scratcher for me.
Yeah.
If reality isn't bound by laws, then how does anything work?
Well, the author suggests that what we call laws are just human descriptions of the inherent properties and tendencies of this underlying reality.
Okay, so it's like give me an example.
Imagine a river flowing downhill.
Okay.
So we describe that as gravity, right? But the river isn't consulting a physics textbook. It's simply expressing like an inherent characteristic of the system.
So the universe isn't following rules.
Right.
It's just being itself.
Exactly.
And those inherent properties are what we perceive as laws.
That's the shift.
That's a huge shift in thinking.
It is. And that's actually where the author's critique of our current physics theories comes in.
Okay.
They argue that even our most successful theories, like general relativity and quantum field theory, they might be missing a crucial piece of the puzzle by not fully accounting for this underlying machinery.
So how do we even begin to approach this machinery? Where do we even start?
That is the challenge.
Yeah.
And it's a challenge that might require us to re-examine some pretty fundamental assumptions about how we do physics.
This is a lot to unpack.
It is.
Even just defining this machinery seems like a major hurdle.
Absolutely. But, the author does give us one clue. They suggest that this underlying structure might be continuous rather than discrete.
Okay.
Which has huge implications even for the way we use mathematics.
Right, because math relies on these distinct units and divisions.
Yeah.
So are you saying that our very tools for understanding the universe might be...
Could be.
Part of the problem?
Part of the problem, yeah.
That's fascinating.
It is.
And also a little unsettling.
Yeah, I mean, how does this continuous nature of reality then explain, things like the probabilities we see in quantum mechanics?
That's a good question.
Yeah.
How does that fit in?
That's something we're going to dive into more.
Okay.
The author has some thought-provoking ideas about how our current interpretations of probabilities, might be putting the cart before the horse.
Okay.
But first, let's explore some specific examples where this whole machinery concept could change our understanding of some pretty well-established physics.
All right, sounds good.
Yeah.
So I'm starting to get how this idea of like a continuous reality could challenge our current physics models.
Yeah.
But how does it fit in with theories like general relativity and quantum field theory?
Right.
I mean, they're incredibly successful
at
explaining so much of what we observe.
Right. Well, that's where it gets really interesting.
Okay.
The author points out that even these theories might be built on kind of a shaky foundation.
Okay.
If they're missing this fundamental understanding of the machinery.
Can you give me an example? Like, where might that be the case?
Sure. Take general relativity.
Okay.
It describes gravity as a curvature of space-time caused by mass and energy.
Right.
But what is space-time really?
Yeah.
And how does it interact with energy at this fundamental level?
Those are still open questions.
They are.
General relativity describes the effects beautifully.
It does.
But it doesn't really explain the underlying mechanism.
Exactly. And the author argues that a similar issue comes up in quantum field theory. We have these fields that permeate all of space. And particles are excitations of those fields.
Right.
But how do these fields interact with space-time?
Okay.
And what is the underlying structure that gives rise to these fields in the first place?
So both of these theories, which are considered like the pillars of modern physics, might be missing this key piece of the puzzle.
They might.
By not addressing the machinery directly.
That's what the author is saying. And they even suggest that string theory,
oh, wow,
which attempts to provide a more unified picture of the universe, still falls short.
Why is that?
Well, it offers some intriguing possibilities.
Okay.
By introducing this idea of tiny vibrating strings as the fundamental building blocks of reality.
I thought string theory was supposed to be the answer to everything.
Well,
like the theory of everything.
It does, you know. But even string theory relies on these concepts like space-time and fields, which the author argues, might need to be completely reevaluated in light of this machinery concept.
So even our most advanced theories might need a serious overhaul.
It seems that way.
If we're going to incorporate this new way of thinking.
Yeah.
But I'm still struggling with this idea that reality doesn't read laws.
I understand.
It seems so counterintuitive to everything we've learned about the universe.
I know it's a big shift, but think about it this way.
Okay.
The laws of physics, as we understand them, are based on our observations and our mathematical models.
Okay.
They describe how things behave, but they don't necessarily explain why.
So the author is saying these laws are more like descriptions and prescriptions.
Yeah.
The universe isn't following a set of rules. It's just expressing its inherent nature.
Exactly.
Okay.
Imagine like a school of fish swimming in these synchronized patterns.
Yeah.
We can describe their movements with mathematical equations, but the fish aren't consulting those equations.
Right. They're just doing their thing.
They're just responding to each other and their environment in ways that are determined by like their biology and their instincts.
It's a great analogy.
Yeah.
It helps to visualize how complex patterns can emerge from these simple localized interactions without needing some overarching set of rules.
Precisely. And this brings us to one of the most challenging aspects of the author's argument.
Okay.
The idea that there are no true parts in reality.
Okay.
That even particles are more like temporary patterns within a continuous whole.
This is where I really start to get lost.
Yeah.
How can something be both a pattern and a thing?
Is a difficult concept to grasp.
Yeah.
But the author suggests that our perception of separate objects is kind of a necessary illusion for us to navigate the world.
Okay.
Think about like a whirlpool in a river.
Okay, I'm picturing it.
Yeah.
It has a definite shape. It spins.
Yeah.
It can pull things in.
Right.
It seems like a distinct entity.
It does, but is it really separate from the river itself?
That's a good question.
The whirlpool is simply a pattern of water movement.
Okay.
It arises from the flow of the river and eventually dissolves back into it.
So are they saying that particles,
Yeah.
even larger objects like trees and rocks,
Possibly.
are like whirlpools in the river of reality?
That's one way to interpret it.
Just temporary patterns within this larger interconnected flow.
Exactly. And this ties back to the author's point about the limitations of the scientific method.
Okay, let's dive into that.
Yeah.
How does the scientific method limit our understanding in this context?
Well, the scientific method relies on observation,
Right.
measurement, and experimentation.
Right.
To do this, we have to separate the observer from the observed.
Okay.
Isolate systems define variable.
Right. We create these controlled environments to make sense of things.
Yeah.
That's how we test hypotheses and build reliable knowledge.
Absolutely. But the author argues that this very act of separation might be obscuring the true nature of reality. We're so focused on isolating and analyzing these individual components that we might be missing the interconnectedness of the whole.
It's like trying to understand a symphony by only listening to one instrument at a time.
Exactly.
We might grasp the individual parts, but miss the overall harmony and how the instruments relate to each other.
That's a great way to put it, and this is where the author's ideas start to challenge.
Yeah.
Not just our scientific models, but our very way of perceiving the world.
It's a mind-bending shift in perspective.
It is.
But if our current approach is so limited, how do we even begin to study this machinery and its continuous nature?
Yeah.
It seems like an insurmountable task.
It's a question the author doesn't fully answer.
Okay.
But they do hint at the need for new mathematical tools. New ways of thinking, and perhaps even a re-examination of some of our most fundamental assumptions about the universe.
Well, I'm starting to understand why these notes are so intriguing, even if they leave us with more questions than answers.
That's the beauty of exploring the frontiers of knowledge.
Yeah.
It's not always about finding, definitive answers.
Right.
But about asking the right questions and challenging ourselves to consider new possibilities.
And speaking of questions, one thing that's been bugging me is how this continuous view of reality squares with our experience of randomness and chance.
Right.
Especially in quantum mechanics, probabilities seem to play a fundamental role.
Yeah.
How does the author address that? It's true, the idea of a universe without, these distinct parts seems at odds with all the randomness we see in quantum mechanics. After all, probability implies separate events, right?
Right.
How does this all fit into the author's framework?
Well, that's a key question.
Yeah.
And the author kind of tackles it head on.
Okay.
They argue that our current interpretations of these quantum probabilities might be putting the cart before the horse.
Okay, what do they mean by that?
Okay, so think about it this way.
Okay.
We observe certain phenomena in the quantum world that seem random.
Okay.
Like the decay of a radioactive atom.
Right.
We can use probabilities to describe the likelihood of that decay happening at any given moment.
Right.
But we don't know exactly why it happens when it does.
It's like rolling a die.
Yeah.
We can predict the odds of each number.
Exactly.
But there's an element of chance involved in each individual roll.
Right. And the author argues that attributing this chance to some inherent randomness in the universe could be a mistake. Instead, they suggest that what we perceive as randomness might be a result of our incomplete understanding of this underlying machinery.
So are they saying there's a hidden determinism beneath the apparent randomness?
Not necessarily. They're not arguing for a strictly deterministic universe. But instead, they propose this fascinating alternative. Imagine this underlying machinery as a vast interconnected system. Constantly evolving and changing.
I'm following so far.
Now, our limited human perception and our current scientific tools, they can only capture these snapshots of this system. Like individual frames in a movie.
So we're only seeing glimpses of the process, not the whole picture.
Precisely. And because we're missing the full context of these snapshots, we interpret certain events as random when they might actually be perfectly logical consequences of this underlying machinery working as a whole.
So the randomness is just an artifact of our limited perspective.
Could be.
It's not that the universe is inherently random. It's that we don't yet have the tools to see the full picture.
Exactly. The author even uses this provocative phrase. Chance is just a calculator.
A calculator.
It's a tool we use to quantify our limited understanding.
I see.
Not a fundamental feature of reality itself.
So this is a pretty radical departure from how we usually think about probability and chance.
It is.
It's like saying the unpredictability of the weather isn't due to some inherent randomness in the weather, but because we just don't have a perfect model of all the atmospheric variables.
That's a great analogy.
Yeah.
It highlights a crucial point. The author isn't saying that probabilities are useless or wrong. They're still valuable tools for describing and predicting, certain phenomena.
Right.
But they shouldn't be mistaken for the underlying cause of those phenomena.
So instead of seeing probabilities as these fundamental aspects of reality, we should be looking for that deeper machinery that produces the patterns we observe, even the ones that appear random.
Exactly. The author suggests that focusing on the machinery could lead us to a more complete and satisfying explanation of the universe.
Okay.
One that doesn't rely on chance as like a fundamental principle.
This has been an incredible deep dive.
It has.
Into some really mind-bending ideas.
Yeah.
I'm starting to kind of grasp the implications of this machinery concept.
Yeah.
But I gotta admit, it's a lot to wrap my head around.
I agree. It challenges our intuitions.
Yeah.
And it forces us to question some very fundamental assumptions.
For sure.
About how we understand the universe.
So for our listeners who are on this journey with us, what are some key takeaways they should consider as they continue to explore these ideas?
Well, first, I think the author's core argument is incredibly thought-provoking. You know, our current physics, while successful in many ways, might be overlooking a deeper level of understanding.
Yeah, and this deeper level might involve a very different picture of reality.
Yes.
One that's not built on separate parts interacting through forces, but on this continuous and interconnected machinery that we don't yet fully comprehend.
Exactly, and this leads to, you know, a reevaluation of some fundamental concepts, like chance and even the laws of physics themselves.
It also suggests that our current scientific tools and methods might be limiting our ability to fully grasp this deeper reality.
Absolutely. We might need new ways of thinking, new mathematics.
Wow.
Even new ways of perceiving the world.
That's a daunting prospect, but also incredibly exciting.
It is.
The author leaves us with more questions than answers.
For sure.
But they also point us in a new direction.
Yes.
A path towards a potentially more profound understanding of the universe and our place within it.
Well said.
This has been a truly thought-provoking deep dive.
It has.
And I hope our listeners are as intrigued by these ideas as we are.
Me too.
What are your final thoughts?
You know, the author's notes offer this fascinating glimpse into a potential future of physics, one that's both challenging and exhilarating.
Yeah.
It reminds us that our quest for understanding is never truly finished.
That's true.
And that there's always more to discover.
Well said. And on that note, I want to thank our listeners for joining us on this mind-bending journey.
Yeah, thanks everyone.
We encourage you to continue exploring these ideas.
Absolutely.
Ask your own questions.
For sure.
Share your thoughts with others.
Yeah.
Until next time, keep diving deep.
Yeah.